Then we come towards the nuclear forces. These forces exist among the nucleon pairs. The nucleon pairs are pp, that is the proton-proton pair. Then it is NN pair, that is the neutron-neutron pair. And then it is proton-neutron pair. Now, these forces may be attractive or repulsive. That depends upon what is the critical separation among the nucleons. If we find that the critical separation is between 0.5 Fermi to 3.8 Fermi, the nucleons have tendency to attract. So, attractive nuclear forces will dominate. So, Fermi means 10 to the power minus 15 meters or 10 to the power minus 13 centimeters. Then the forces can be repulsive if the separation among the nucleon pairs is less than 0.5 Fermi. The nuclear forces or the nucleon pairs will begin to repel, and the forces within the nucleons will be the repulsive forces. Another will be if the range or if the distance among the nucleons exceed 4 Fermi, then the repulsions or attractions vanish and the nucleons fly off. So, range of nuclear force is approximately 1 Fermi to 4 Fermi. Moreover, the strongest force in our nature is nuclear force, another one is electrical, and the weakest is gravitational. So, we can say that nuclear force is greater than electrical force, and electrical force is greater than, that is, gravitational force. Normally, it is found that nuclear forces are stronger than electrical forces by 35 to 100 times, and nuclear forces are stronger than gravitational forces. That is, first comparison is between nuclear force and electrical force, that is 35 to 100 times. And if we make a comparison for gravitational, then nuclear forces are stronger than gravitational forces by 10 to the power 34 times to 10 to the power 39 times. So, whatever caption is coming, that is already explained. This force acts within the nucleus of an atom. So, atom is bigger as compared to nucleus. Nucleus is a central part of the atom, made up of at least protons or made up of protons and neutrons. Atom is neutral, but nucleus is positively charged. Nature of this force is unknown and it has unique properties. So, the limitation is the forces can be repulsive or attractive, as I have explained earlier. Therefore, it is called a very strange force. This force is maximum inside the nucleus and zero outside the nucleus. The range of the forces is of the order of 10 to the power minus 15 meters. Its energy particle is pion. When we use the term pion, we are referring to positive meson, the negative meson, and the neutral meson. The family of mesons is called pions. So, pions means either it will be a positive meson, or it will be a negative meson, or it will be a neutral meson. These particles were first of all discovered by a Japanese scientist, that is Yukawa. These particles were first of all observed in a sample of cosmic rays at a height of about 400 kilometers above the sea level of the Earth. Nuclear forces do not depend upon the charge. It is the charge-independent force. This force acts between the proton pairs, the neutron pairs, and the neutron-proton pairs. Weak forces. Now, the weak forces, as I have explained earlier, beta decay in a radioactive disintegration is explained by this force. Radioactive, that means nucleus, the disintegration of nucleus. And radioactivity means that is the radiation given out by an element in its normal state. This force is weaker in comparison to the nuclear and electromagnetic forces and is 10 to the power minus 25 times the nuclear force. The range of this force is of the order of 10 to the power minus 15 meters. The energy particle of this force is boson. Like meson, bosons are also subatomic particles. Now, the two equations are indicated in this particular context. First equation is 0 and 1, means 0. Normally, the rule is we write 0 downward and 1 upward. But now, according to the modern convention, we write charge at the top right index and 1 at left base. So, 0 is the charge of neutron and 1 is the mass. So 0 and 1 decays into a proton, beta particle and antineutrino. Well, beta particle is a high energy electron. So when we speak beta particle, it is negatively charged particle and mass is exactly equal to that of electron. But there is difference between the beta particle and electron. Electron is uh, a particle existing in orbit. It is revolving around the nucleus, whereas beta particle is originated from the nucleus due to decay of neutron. The another equation is related to proton decay, that is 1p1. 1p1 decays into 1 and 0, that is neutron, and one positive beta particle, that is called positron, and nu is neutrino. This force is related with the transformation of neutron to proton or proton to neutron in a beta decay. This nature of weak force is still unknown. Now we come towards the inertial and the gravitational mass. We consider the laws of motion. The second law of motion states that F is equal to ma. So A is equal to F over m. This m is called the inertial mass. That is, inertia is the basic property of all the masses. We can't expect a body without inertia. And inertia is the property due to which the body has change in state. Moreover, when we speak gravitational mass, we take the weight of the body. Weight of the body means F is equal to mg and m is equal to F over g. So what we find is that in both the cases, there is the formula is either F over A or F over mg. So the gravitational mass and the that is called the inertial mass numerically are the same. Now, inertial and gravitational masses, mass can be defined in two ways. Mass is the quantity of matter contained by body. So by Newton's laws of motion and by Newton's laws of gravitation, according to Newton's second law of motion, if a constant force is applied on a body, produces an acceleration A in that body. So a mass can be calculated by function F over A. This mass is called the inertial mass. It is proportional to the quantity of matter present in the body. It is independent of the shape, size, and state of the body. It is not affected by the presence of other bodies near it. When various masses are put together, the inertial masses add according to the scalar laws, irrespective of the material of the bodies involved. Now, this equation is given as the consequences of the special theory of relativity. It was first explained by Einstein in 1905. According to this equation, it has been clarified that if the body is in rest, it has a different mass, and if the body is moving, it will be having a different mass. So when the body is moving, the moving mass is indicated by m. m naught is supposed to be the rest mass. Then v stands for velocity and c stands for velocity of light. So whenever mass is moving, the moving mass is given by Einstein's special equation, that is called m naught over under root 1 minus v square over c square, where m naught is the rest mass of the body and c is the velocity of light. V is the velocity of particle. Particle means mass m. Velocity of light is supposed to be 3 into 10 to the power 8 meters per second, and it is calculated by Maxwell equation. The Maxwell equation is that c is equal to 1 over under root of epsilon naught into mu naught. Now we are coming towards certain examples and their solutions. Now suppose that an object has mass root 3 kilogram. Now root 3 means 1.73 kilograms, is moving with velocity, and that velocity is 1 over 2 the velocity of light. So if the velocity of light is c, then the velocity of that mass is c over 2. Then inertial mass will be how much? So we use the equation m is equal to m naught over 1 minus v square over c square. Then we compute the values. For v, we can compute c over 2 and then we take the square. So it will become c square over 4. So after net calculation, the value becomes 2 kilograms. So moving mass of the body whose earlier mass, whose rest mass is root 3 kg will be 2 kg. According to Newton's law of gravitational force, like Earth, the gravitational force of attraction F produces an acceleration g. Then F or W, F means force, weight means force, that is equal to mg. So m is equal to F over g, and m is called the gravitational mass. The value of F can be written as Fr square over gm. The mass is obtained from the gravitational force F, and the acceleration due to gravity g is called gravitational mass. Even with the most sensitive instruments available, no difference has been detected between the values of the inertial and gravitational masses. So they are numerically the same. So inertial mass is equal to gravitational mass numerically.